When you think of a volcano erupting, what comes to mind? Probably a huge mountain spewing fire, ash clouds billowing into the sky, and rivers of glowing lava. It's dramatic, it's terrifying, and it's what we see in movies. But what if I told you that one of the biggest volcanic threats on our planet is completely invisible? What if a major eruption was already happening, and we didn't even know it? This isn't science fiction. This is the hidden reality of supervolcanoes and large volcanic systems that don't look like your typical cone-shaped mountain. Forget everything you think you know about volcanoes. The real giants, the ones with the power to alter our climate and disrupt civilization on a global scale, often don't have a peak at all. They're called calderas, and they're essentially massive craters, depressions in the ground left behind by ancient eruptions of unimaginable scale. Places like Yellowstone in the United States, Campi Flegrei in Italy, and Lake Toba in Indonesia are all supervolcanoes. From the ground, you might not even realize you're standing in the middle of one. You might see hot springs, geysers, or steaming vents, but the sheer size of these systems makes them hard to comprehend. These are not your everyday volcanoes. A supereruption is defined as an event that ejects over 1,000 cubic kilometers of material. To put that in perspective, that's enough ash to bury an entire continent. The 1980 eruption of Mount St. Helens, a major event by any standard, ejected about 1 cubic kilometer. So we're talking about something 1,000 times bigger. An event like this would be a global catastrophe, plunging the world into a volcanic winter, causing widespread crop failures, and fundamentally changing life as we know it. The scary part is that these systems are very much alive. Right now, under the picturesque landscapes of places like Yellowstone, a massive chamber of magma is slowly churning. We know this because the ground is constantly breathing. In recent years, scientists have recorded significant ground deformation in these areas. The ground is literally rising and falling, sometimes by several centimeters a year. This is a direct sign that something is happening deep beneath the surface. Magma is moving, gases are accumulating, and pressure is building. Take Campi Flegrei, near the bustling city of Naples in Italy. This is one of the most dangerous volcanic areas on Earth. The ground here has been rising and falling for decades, a phenomenon known as bradyseism. In the early 1980s, the ground rose so fast that a whole town had to be evacuated. And just recently, the area has been experiencing thousands of small earthquakes, a seismic swarm that has residents on high alert. These aren't just random tremors. They are the cracks and groans of the Earth's crust straining under immense pressure from the magma below. This is the invisible eruption. It's not the dramatic explosion, but the slow, relentless buildup. We can't see the magma, but we can measure its effects. We use an incredible array of tools to keep an eye on these sleeping giants. GPS stations track ground movement down to the millimeter. Seismometers listen for the faintest of tremors, the telltale signs of rock fracturing under stress. Gas sensors sniff the air for changes in volcanic gases like sulfur dioxide and carbon dioxide, which can indicate that magma is rising closer to the surface. This monitoring is a race against time. The more we understand these systems, the better we can predict their behavior. But predicting a supereruption is one of the greatest challenges in modern science. We're dealing with geological timescales, processes that happen over thousands, even millions of years. And our direct observational record is just a tiny snapshot. We have records of past supereruptions from geological evidence, massive layers of ash found thousands of miles from their source. These layers tell us how often they happen, which is roughly every 100,000 years or so. The last one was about 26,000 years ago. So statistically speaking, we're in the window. But statistics don't tell us when the next one will be. It could be in 100,000 years, or it could be next Tuesday. The key is to watch for the warning signs, the precursory activity that will almost certainly happen before an eruption of this magnitude. This activity would likely be on a scale we've never seen before. We're talking about intense earthquake swarms, dramatic and rapid ground uplift over a huge area, and massive changes in the geothermal system, like geysers erupting constantly or new steam vents opening up. So how do we prepare for a threat that's so big it's hard to even imagine? It starts with science and monitoring. Governments and scientific institutions around the world pour resources into volcano observatories. These are the front lines in our defense against this hidden threat. Scientists work 24/7, analyzing data, running models, and trying to decipher the language of the volcano. Their goal is to provide as much warning as possible, to give people time to evacuate and for governments to prepare. An evacuation from an area like Yellowstone or Campi Flegrei would be an unprecedented logistical challenge, involving millions of people, but the immediate danger zone is only part of the problem. The bigger issue is the global impact. An ash cloud from a super eruption would spread around the planet in a matter of days, blocking out sunlight. This would trigger a rapid drop in global temperatures, a volcanic winter that could last for years. Imagine summers without sun where temperatures are so low that nothing can grow. This would lead to global food shortages and famine. The ash itself is also a problem. It's not like wood ash. It's made of tiny, sharp particles of rock and glass. It's heavy, and when it gets wet, it can be like concrete, causing roofs to collapse. It contaminates water supplies, destroys machinery, and is a serious respiratory hazard. Air travel would come to a complete standstill, crippling the global economy. This sounds like an apocalyptic scenario, and it is. But it's important not to panic. The probability of a super eruption happening in our lifetime is still very low. However, the potential impact is so high that we have to take the threat seriously. It's a classic example of a low-probability, high-consequence event. That's why the scientific community is so focused on improving our understanding and monitoring capabilities. What can you do? Stay informed. Understand the science. Support the funding of geological research and volcano monitoring. If you live near a volcanic area, even one that seems dormant, be aware of the local emergency plans. But more than that, it's about appreciating the incredible forces that shape our planet. We live on a dynamic, breathing world, and these invisible giants are a powerful reminder of that. They are not evil monsters bent on destruction. They are a natural part of the Earth's life cycle. The story of these hidden volcanoes is a detective story on a planetary scale. Scientists are piecing together clues from the deep past and the present day to understand what makes these giants tick. Every earthquake, every inch of ground uplift, every puff of gas is a piece of the puzzle. We may never be able to stop a super eruption, but by watching and listening, we can learn to live with the invisible giants beneath our feet. We can unmask the threat, and by understanding it, we give ourselves the best possible chance to prepare for it. Thank you for watching. If you found this journey into the world of hidden volcanoes fascinating, please hit that like button and subscribe for more deep dives into the wonders and dangers of our amazing planet. Stay curious and stay safe.